The art of paper folding. It comes from the Japanese words ori, which means folding, and kami, which means paper. This paper making is believed to have originated in the 1st or 2nd century China by a servant of the Chinese emperor. The art of paper folding eventually made its way to Japan around the 16th century. However, because paper decomposes rapidly, there is very little direct evidence of its age or origins, aside from references in published material. It started as an art for the rich, as paper was expensive. The samurai would exchange gifts in a form known as a noshi. This was paper folded with a strip of dry rice or meat. It was considered a good luck token. As easier paper-making methods were developed, paper became less expensive. Origami became a popular form of art for everyone. The first book to teach origami was in 1797, called How to Fold 1,000 Cranes. Before this, ancestors passed down the art to new generations. This book contained the first written set of origami instructions, which told how to fold a crane. The crane was considered a sacred bird in Japan. It was a Japanese legend that if a person folded 1,000 cranes, they would be granted one wish. Moors, who were from Africa, brought paper folding with them to Spain when they invaded that country in the 8th century. From Spain, it spread to South America. As trade routes were developed, the art of origami was introduced to Europe and later the United States. While origami may seem like just an art form, it has plenty of practical and mathematical uses. A number of technological advances have come from insights obtained through paper folding. For example, techniques have been developed for the deployment of car airbags and stent implants from a folded position, stent being an artificial tube used for medical reasons. There is also the problem of rigid origami. That is, say, if we replaced the paper with a sheet of metal and had hinges in place of crease lines, could we still fold the model? This is of great practical importance. For example, the Mura map fold is a rigid fold that has been used to deploy large solar panel arrays for space satellites. Also, there may soon be an origami airplane launched from space. A prototype passed a durability test in a wind tunnel on March 2008, and Japanese Space Agency adopted it for feasibility studies. People who spend time folding paper often ask themselves questions that are ultimately mathematical in nature. Is there a simpler procedure for folding a certain figure? Where on the original square paper do the wings of a crane come from? Why do so many origami figures start with a square paper? What size paper should I use to make a chair to sit on at an origami table I have already made? Questions such as these have recently inspired a special branch of mathematics dedicated to origami. We have learned from that origami can be applied in mathematics on many levels, from calculating simple formulas and areas of surfaces to building large-scale space telescopes using origami rules to compact the inside. It has endless possibilities for creating polyhedrons. In many classes in both Canada and the United States, origami is used in classrooms to help kids learn math in a fun way. It gives many kids a hands-on look at how math works. The origami cube is a great example of this. you may watch my tutorial on how to make an origami cube included with this video. Once the cube is made and unfolded, it looks like this. As you can see, the length of x by the middle square, made up of 4 tiny squares, is 1/4 the length of a. Therefore, if one side squared, a squared, is the area, then 4 times x squared must also be the area. Another example of mathematics shown in origami is simple fractions, which I will show you in the mini tutorial performed by myself. I'm about to show you a lesson about fractions that can be taught with origami and a square piece of paper. Now, as you can see, this paper is completely square, and we're going to make reference to it later. But first we have to fold it in half one way, make sure it's nicely folded, unfold it, fold it in half the other way. So now we fold it in half twice. Should make this easier. When we take one of the vertices and we fold it into the center, kind of like a triangle. Do the same thing for all the other sides. Now that all these flaps are in, we now have a new square. Now, kids can see that this square is exactly 1/2 the size of the original square, and I'll explain why. See each of these flaps? We can see that each of these flaps is exactly 1/4 of the square, since there are 4 of them and they cover the entire square. Now, when we unfold the model and see the original square, we can see the fold outlines for these triangles in like tiny squares. As you can see, the square goes all the way around here. Another square right there. You can see our folded triangle piece, the flap that covers it, is exactly 1/2 of this square. And this square is 1/4 of the entire square, like this big square. So this is half of the 4th, so this is 1/8. And since we're folding it over, we're pretty much getting rid of it from visible sight. We're moving it from the area. So when we fold all of them, we're effectively getting rid of 4 1/8. 4 times 1/8 is 1/2. So we're taking off 1/2 of the area, so the new square has exactly 1/2 of the original area. Lessons such as these have been helping kids understand and really take an interest in math from grades 1 up to high school. One very interesting math problem which spurred from origami is the infamous how many times can you fold something in half? Many people believe that you can only fold a piece of paper or anything in half 7 or 8 times, no matter what the shape. But in April 2005, Brittany Gallivan folded a sheet of gold foil in half 12 times and later a piece of paper in half 12 times. She discovered the limits to folding involve both the width of the paper and the thickness of the paper, and are expressed in this formula. N is the number of times the paper is folded. W is the width of a square piece of paper, and T is the thickness, expressed in the same units. There is a book written on this problem, How to Fold a Paper in Half 12 Times, an impossible challenge, and it explains the solution to a time-old brain teaser. As you can see, origami has not only been an important part of the past, but it is also helping to improve our future. There are endless possibilities for origami applications in the math world, and mathematicians are just beginning to explore them. Origami is able to help not only scientists, but also students who may become future scientists. It is a great pastime, art, and brain worker, and I advise anybody just to make something for fun sometime. You never know, you might really enjoy it.